Passive house testing. We made it, folks. We are here at the actual webinar. So what we're going to do here is we're going to get into it. We're about 10 minutes in. We have a lot of stuff to cover, and make sure that you still ask questions whenever you feel. Today we have myself, Jay West. I am more than just a nice guy from out of town. I am actually an independent trainer for Retrotech. That's me. That's me smiling. I got some darker glasses now. Doesn't look like Joe's gonna be with us today, so there will be just me on the back end answering questions. So I'm sorry if it's a little bit slow today about answering questions that you type in, but please don't feel afraid to. And here's my guy right here, Kevin Brennan, ladies and gentlemen. Kevin Brennan, Passive House Academy, building science consultant and trainer. This is Kevin's email. Email him anytime, day or night. With any question you want, and especially if you're a prince from Nigeria who needs some money or anything like that. I kid you, but Kevin, tell us a little bit about, very quickly, about Passive House Academy and what you do for them, because I know that it says here that you're a consultant, building science consultant and trainer, but I think you do a lot more than that.
Thanks, Jay. Kevin Brennan from the Passive House Academy. The Passive House Academy is an international certifier that is certifying to the Passive House International Standard. I have joined on board with the Passive House Academy a few months ago. I'm their New York City representative and their U.S. representative. We've been doing training in the U.S., teaching the Passive House tradesperson training for a little over 3 years now. Soon to be coming to a city near you, that hands-on tradesperson training, teaching people how to make buildings as tight as they possibly can with those high-performance air tightness materials, strategies, and techniques. As far as the other hats that I wear as a building science consultant, I am out in the field testing buildings, hopefully meeting that Passive House air tightness standard, and helping to find those little air leaks throughout different buildings. So that current picture you're looking at right there with that happy face on, making a hand gesture of why you're taking my picture, Jay, that is at our facility in the Bronx that teaches about Passive House air tightness. That structure itself demonstrates all the techniques and all the mistakes you can possibly make in a building and still achieve Passive House air tightness. So that's my story. I'm sticking to it, and let's go on with the webinar. You got the mic, Jay.
Yeah, hey, Kevin, actually, before you go away, tell us a little bit more about your private life. I mean, can we hear about, not too private, but you are a New York City fireman, and you know, I think it's sort of important to tell people a little bit more about your background as well. And where did you come from? How do you know this stuff?
Thanks, Jay. Thanks for the lead-ins. My first job was in weatherization, so I was crawling around attics, sealing up air leakages in roughly age-old homes, crawling around that mummy dust, and doing blow-a-door testing, trying to achieve weatherization air tightness. I then joined the New York City Fire Department a little over 10 years ago, and I'd like to continue my passion of being in the energy efficiency world. So on my nights, weekends, and part-times off from the fire department, I'm able to participate in the community as a trainer and as a building scientist, and still doing testing. But the jokes we throw around is that finding air leakage under high pressure in fires is rather easy. When you're trying to find it under ambient pressure of regular buildings with blower doors that's invisible, that's the hard stuff. So my job with the New York City Fire Department is it's a great passion of mine, providing light safety to the city, but that equal passion goes into energy efficiency. So one day, hopefully.
Hey, Kevin, can you tell us what house you're out of? Is that I can't remember if that's okay to do.
That's fine. It's in the South Bronx, so it's a nice company in the South Bronx. So.
All right, thank you. So this is what we're going to talk about today. This is we're going to talk a little bit about tests that you need to use, or tests that you need to do to qualify a passive house. We're going to talk about and this is where Kevin's going to talk a little bit about his perspective on why there's been such an increase in passive house buildings and the sort of buildings and certifications and sort of the spike in interest and production in that. We're going to talk about best practices for testing that you won't find in the standards. I think this is especially important. I talk to architects, engineers, even raters about this all the time. And then we're going to talk about some of the tools for great tests. And this means that it's more than just a regular test. It's a great test. So let's get started. I think ideally the first place to begin with is the basic passive house criteria. So super insulation, thermal bridge-free construction, ventilation with heat recovery, heating and cooling demand that is below that is 4.75 BTUs per square foot, right? This is the European use of the comma, not the North American, right, Kevin? Or is it 4,750?
That is correct. Well, it would be kilobTUs per square foot per year, so we're just showing it in BTUs per square foot. So
Okay.
just a K.
Thank you, sir. And then air tightness is 0.6 ACH at 50. So this is really where our conversation is going to center. I mean, all these things are very, very important, and all of them are, you can't go without any of these and still have a certified passive house. But of course, us being Retrotech, being a manufacturer of pressure stuff, we're going to talk mostly about our air tightness, and we will talk a little bit about testing, ventilation, and heat recovery if we have some time at the end, if we're so lucky. But at first, I want to talk a little bit about the first fully functioning passive house. The first fully functioning passive house is actually a FRAM. This and a FRAM, what does that mean? Well, I asked this last time we talked about this, and I had some people out there in Europe that actually can explain a few things. So, but the sides of the ship, and this is a quote from a book by Admiral Nansen, 1897. He says the sides of the ship were lined with tarred felt. Then came a space with cork padding, next to deal paneling. Deal apparently is a very soft wood that's common in Europe. Then a thick layer of felt, next an airtight linoleum, and last of all an inner paneling. The ceiling of the saloon cabins gave a total thickness of about 15 inches. The skylight, which was most exposed to the cold, was protected by 3 panes of glass, one within the other, and in various other ways. The FRAM is a comfortable abode, whether the thermometer stands at 22 degrees above zero or 22 below it. We have no fire in the stove. The ventilation is excellent, especially since we rigged up the air sail, which sends a whole winter's cold in through the ventilator. Yet in spite of this, we sit here in the warm, comfortable, with a lamp burning. I am thinking of having the stove removed altogether. And this is from 1897. And Fritjof Nansen, I believe. So point is that this actual first sort of passive house was actually a boat. And he mentions the comfort. He mentions the indoor air quality. It's pretty amazing, all these things that were so far ahead. And he also talks about a wall assembly. So what he has here, and what we talk now, what we talk when we talk about airtight building, we actually talk about things that are that are very airtight, actually, and this is how we describe it. No longer is it a FRAM. Now, if you look at the way that it's described by our friends over here at 475 Building Supply. This is a sign that you'll see there. No drilling, no cutting. This is a airtight building. So let's talk a little bit about the tests. How do we define an airtight building? So I'll leave the text up here for you. So you can see it. So the ASTM E779 is a standard method for determining air leakage, very, very common here in North America. The ASTM E1827 is also, I guess, part of that, an extension of it. The EN13829 will probably be the one that you're more familiar with in Europe. And this is a fan pressurized method, ISO 9770.
Both organizations do take an average, and that both organizations do have a standard method of calculating the volume within the building, which is very key.
So So why do they add an average of pressurization and depressurization? Why would you do both?
So in passive houses in every building, certain gaskets or dampers, windows, doors, roof lights, skylights, the gaskets will engage under depressurization, be pulled tighter, and then they will disengage under pressurization. So to get the truest test, they like to see an average of the two. So it's kind of the most fair way to actually give what the true leakage of the building is, because under air, air pressurization due to wind or stack effect or mechanical effect, that those gaskets and those dampers are going pressure and depressurization continually throughout different times. So they're being activated and deactivated.
Thank you. So here's a comparison of the ASTM standard and the European norm standard. How do they differ? And why is it important to know this stuff? Or is it?
So it's important to know that if you follow the ASTM standard straight down the line, it doesn't. It gives very good guidance on test setup and what the boundary conditions are as far as the baseline, but it doesn't clearly state how you need to measure the volume and what actually can be masked over and what cannot. So ASTM does a very good. It's a very good testing method. It just the EN goes to a little bit more detail of what can be masked over and what can't be masked over, and even in Passive House, the definition of that is even further clarified. So having a good relationship with your Passive House consultant and your certifier, and also the person who will be doing your blower door, to make sure that they're doing it to the actual test method that's needed. They are very similar. The other difference is the software that's provided. So the software is able to help you do test compliance by putting in all the data that you need, and the fantastic software helps me out on many of my tests to make sure that I'm hitting all those checklist marks of collecting all of the data needed for those tests.
Great. Yeah. So Fantastic, of course, is the RetroTech software for running a fan. It can run any of these tests as well. Thank you for dropping some names in there. So that's good. I think let's move on. How do you feel about that? So,
Feel good.
no, good.
Just the one thing, the one major thing is the measurement of the volume. So a lot of people say, well, why are you taking a very small volume of sheetrock to sheetrock and not accounting for the internal volume between the walls? It's that the test is very accurate and you're getting your most true number. So by not taking account for that space that in theory is not heated, you're giving your actual heated air volume of room by room, and actually the air that's going to be heated. So it's making sure that you're being safe, but you're not overestimating. So comparing apples to apples on every test, that we can really confirm what the air leakage of the building is.
Cool. So for those of you who are not from North America, or even some of you who are from North America, let me know if you don't know what sheetrock is. Um, I will explain that. Thanks, Kevin. So the ACH at 50, the air changes for 50. For those of you who are wow, that somebody just sent me a link. That's gigantic. Thank you so much. So apparently, well, I've gotten a few notes here that say that the EN 13829 is not valid anymore. That they want to recommend that you use the EN ISO 9972 2015. So I will fix that. Thank you. That's I've got, and then I got another note from another person who said ISO 9972 1996. So 2015, 1996 may be dependent upon what part of the country or part of the world you're in, but just for everybody's, just for the sake of making sure that everybody knows, the EN 13829 is not valid everywhere right now. So I apologize if I made it seem like it was. Point is, we're talking about air tightness and what the standards are. So let's talk about what the standard or what the cutoff is. Here for passive house, it is 0.6 ACH at 50. And again, for those of you who are joining us from Europe, this would be a comma. For you, we use a period. But the point is that this is 6/10 or of air changes per hour at 50 pascals. So let's go into a little bit about how we actually figure that out. So Kevin mentioned something about how we figure out the volume. I just want to say or want to point out a really basic way of thinking about volume. So basically, the volume here is this area. So the conditioned space. Very simple, very basic idea of the volume that we're talking about is what's in the conditioned space. If you have an unconditioned part of the house, a zone, which is generally not found in many of the passive house designs that I've seen, but if you do have some interstitial spaces or places that are inside the walls, as Kevin just pointed out, that aren't part of the conditioned space, we do not include that in the conditioned volume. To go a little bit further, again, some real basic stuff. Basically, what we're talking about is the amount of air that is in that conditioned space and how much of that stuff will leave over the course of an hour at 50 pascals of pressure. And here we're showing depressurization. So you see the blue sort of air being pulled through this fan and out, depressurized, and then it's going to give us, our gauge will give us an estimate. That does not mean that we run the test for an hour, it just means that our gauge will estimate what that would be over an hour. So again, here is a little bit deeper. I'm going to actually just skip this because it looks like I need to update some of these slides anyway. But the point here is that the difference between some of the existing or some of the energy codes that we find here in North America is phenomenal. So here, if you look at the 2009 IECC, actually, which I guess is an international code, but their ACH at 50 is 7. So just so you can physically see, this is the amount of air changes per hour at 50 pascals that they'll allow. In 2012, it went down to 3 in different zones, 4 through 8. The U.S. Building Science says 1.5 ACH at 50. And the passive house certification is down here. So you can see that there is an absolutely massive difference between what the certification or is for passive house as opposed to some of the predominant certifications and some of the goals, the air testing goals that we have here in the United States. So I want to thank again 475 Building Supply, our friends out there in the Bronx for this picture. I know that they didn't take it, but I stole it from one of their slides, and it is beautiful. So what we're talking about here now that we've already discussed some of the codes, and then we talked about some of the updates and some of the codes that I didn't have. I apologize for that. But we also talked about what it takes to certify air sealing or certify that the air tightness certification for a passive house. But let's talk about actually how we find out. So what I want to talk about first is what you'll basically what you're going to need to test. It's very simple. You're going to need a gauge, you're going to need a fan, and you'll need a frame and a panel. So it's very simple, and I want to talk about the three options that we offer and help you to compare these. So first you have your basic blower door. This is our full size. This is the 5,000 fan, which is a newer fan. You'll notice that the plugs are much different, still running off the DM32. Here we have what I call our passive house fan frame, which we call is a 3000 or 3101 fan system. It's basically the same setup, the same gauge, the same sort of frame. The panel is slightly different to house a 300 fan, and this is a duct testing fan. This fan can be purchased there is a European version and an American version, but either way, they fit into the panel. And then you have a third option. So same as the 3101 option, but this one is actually a window frame. It's a smaller frame. You probably saw this in the pictures of Kevin teaching a class. He's actually using this window frame system. And it's a 301 system for the duct tester, and that's in a frame, basically. Okay, but those are also, all three of these are available for purchase as a system. So I want to talk first about the 5000 system, or the 5101 blower door system. So really interesting. The reason why I included these slides just as a little look behind the screen here. I talked to a lot of people at different sorts of passive house gatherings, conferences, meetups, stuff like that, and they asked me, what kind of fan do I need? So the first thing I asked them is, well, what kind of houses do you test? Do you only test passive houses? Do you do any duct testing? Do you just test the shell? Do you test the system? So I want you to keep those type of things in mind as we talk about these different sort of systems. But first question I want to answer is the question that I get about, well, will a full-size blower door actually work on a passive house? Absolutely yes. So you'll notice that I put a little a little calculation up here. So the calculation is based on the fact that this 5000 fan can actually have a 29 or a flow range plate that has a small hole put in it, and that's our 29 flow plug. And that will actually test as low as 5 CFM. So if you add that to a typical size American home, which is a 2,400 square foot home, it will test as low as 1/100th, 1.5, or 0.0156 ACH at 50, which, as we all know, is well within the certification level of passive house. So the answer is that yes, these fans, the 5000 fan can test passive houses absolutely. In fact, for those of you in Europe, it can test, or who don't use the cubic feet per minute. It actually goes down to 8 cubic meters per hour. And it can go actually as high as 6,700 CFM in open air, or 11,383 cubic meter per hour. It's got a 3/4 horsepower motor. It is extremely efficient, extremely sophisticated, and has an onboard speed control. But I think the big thing to take away here is that you have 9 different ranges, and that allows you to choose the perfect setting for any test, whether it be a larger building or a smaller building, a tighter building or a looser building, or even any kind of structure. Another thing is you can change plates, range plates, or range plugs at any time. So that's sort of our full size classic system that you could use. Benefits of it again are that you can test a wide variety of buildings, but it is bigger, heavier. So for those of you who are just testing passive house buildings, or just testing tighter buildings, or want a smaller, lighter one, I talked to a lady a few weeks ago who was a raider in her later 60s, and she just wanted a lighter piece of equipment, so she likes this better. Of course, if you're doing duct testing, again, this is the duct tester, the 301 fan, and can plug in. So I just got a note here about that says, Jay, is this fan likely to overheat after running for a while, as the older fans did, because it has no open lugs at the motor? The answer to that is no. Actually, if you look on retrotech.com, you'll see that some of the specifics about our newer inducer fan and the fan housing, and why it can run longer, harder, and faster at lower heat. So I'm glad you did ask that. Yes, for those of you who are worried about overheating fans, this fan actually will run for a longer amount of time at less heat. Anyway, so the Retrotech, we built this fan. It's the first automated what we built is the first automated back pressure compensated flow chamber. So we did that so that we can improve the accuracy under all conditions. And I wanted to point that out because I want to talk a little bit more about how accurate this fan is, and how reliable it is. So you can test with this fan. It's also very powerful and very accurate, so you can test a wider range of tight houses. It's more power, it's a lot less weight, and it has the ability to run for hours on batteries as well. So for those of you who are testing houses who don't have electrical service, you can actually run this on batteries. It's not a battery it's a third party or aftermarket part, but you can still run it on batteries. It's super tight. It's designed to allow you to measure flows down to 5/1000th of a CFM. That's 2/1000th of a liter per second, and that's low enough to measure a light switch or the leakage of a single nail hole. So that's very, very, very accurate and very, very specific. I want to look at some questions. Does Energy Conservatory offer blower doors that can test passive? I'm sure they do. But you'd have to ask them, Neil. They do. In fact, I know that you can use a duct blaster to test a passive house, and you can actually, if you have an Energy Conservatory fan, you can still use the DM32 to run it. If you want to use our software or if you want to use our equipment. It says, is my 3000 series Q4E fan suitable for passive house testing? Mr. Owens, that is going to depend on how big the building you're testing is. But I would recommend that it really is going to be dependent. If it's actually too small of a building and the leakage is too slight, or the actual volume of air, size of the amount of air that you're moving is too small, you might have problems with the 3000 series, the QE fan. Another question here. Can you talk about what type of batteries are suitable? I have a 300 fan also and would love to run it off grid at times. Any ideas? So that I'm going to have to recommend that you take a look online. That's kind of a moving target as far as what I recommend, because that technology, the battery packs are changing all the time. But I would definitely look online, especially because I'm not sure if you're running on 120 or 210. I'm sorry, 220 or 110, whatever it takes, as Mr. Bond would say. All right, so but yeah, most likely not. Thanks, Jay. As far as the 300. So let's move on to the next slide, and thank you for all your questions. I wanted to give you a little bit of a look at this actually inducer motor. So do we have any Germans on the call? Because I want to thank you guys so much for this impeller that's designed to run 100,000 hours. This is a big, big difference from any of the other duct testers or duct blasters that you're going to see on the market. You'll notice that the way that this is built, it actually is not this typical fan that you would see, a propeller-based fan. It's an impeller, and that makes it run faster for longer and cooler. So it is an extremely accurate and extremely powerful. That's why this little bitty piece of equipment can move so much air and so accurately. Kevin, you still there?
I'm here, buddy.
All right, stay
I
away.
actually just did a confirmation test of an in-progress passive house. It was 4,000 square feet. I did it with the little blower door fan, the little 300 fan, and it was giving me around 325 as my CFM rating, and it was right at 0.83 on that project. So they just got a little more work to do.
Thank you. So I did get a question here that what's the other piece of equipment next to the blower door fan? If you're talking about this one, I think this is just a picture of a person actually putting in that additional plug. But I will actually talk a little bit more. Sorry, let's flip back over to where we were. I think we were right here. So another point or another explanation of why this fan is so accurate is you'll see right here, what you're looking at right here is a super tight, well, what's allowed us the super tight tolerance is totally injection molded flow measurement parts. So as you're seeing here, these are all injection molded. So they're actually one piece. Flow pressure pickups that have guide fins. So these are guide fins around these pressure pickups. So that means that the air, if we're getting any sort of heavy turbulence, it's not going to move sideways across. So only the air that's moving straight through across that pressure pickup is going to get in there. I shouldn't say only, but vast majority of it. So as far as we know, as far as I know, nothing has ever been built with so much flow measurement innovation. Nothing that I've heard about. So, and then I'm going to bring it up here. This is basically how this piece of equipment comes. You'll get it with a 74, a 47, and a 29 plug. So this goes very, very tight and still moves quite a bit of air. All right, some questions that I have. Um, an EBM PAPS fan apparently is very, very excellent. Thank you, Mr. Hook. It says with the little fan, and that is a I think you're referring to the duct tester. Is the certain volume it can go before you have to use a bigger fan or a second fan? Yeah, absolutely. No matter what, this fan, as you can see, the reference that the size of the human hand here that's putting that fan or putting the parts on, you can see this fan just is going to be limited by the size of the opening that it actually has. So if you have a house that is, I think, over, say, 3,000 to 4,000. This is just an estimate off the top of my head. But if you have a very big building that you're testing, or a very big home that you're testing, you're going to, even though the air changes per hour might be lower than 0.6, the actual amount of air across that are trying to get through that fan might be too large. So you might want to run a full-size fan. All right, so yeah, in that case, yeah, excellent question. You want to run a full-size 5,000 fan. Or you can try and you can use multiple fans, multiple smaller fans with the Fantastic software and run it as a multiple fan test. I think, but you would have to check locally to see if you can actually do that according to your certification. So last part or last frame that I wanted to talk about is this actual passive house window frame. The window frame is pretty cool. So it allows you a lot of versatility. It's an aluminum frame. It was designed to test the world's tightest passive houses. It has special square corners that provide a full seal right into the corners of the frame. That means that the benefits of sort of using a window frame to test rather than a door frame to test a passive house, one is that no matter what, since you have less connection from the door frame to the housing of the window or door, but here with the window, you're going to have absolutely less leakage. That's a big thing. The other thing is that it's just lighter. I mean, this piece of equipment, as you can see, is very small. It's about 16 American pounds. I'm going to say 7 kilos. I think that's about right. So it's very, very light. So if you're testing, say, your pressurization or your depressurization test that you're trying to get the average of, well, you can move it from window to window. That's also very important. You're going to spend a lot of money getting these very nice triple pane, thermally broken windows into these passive houses, and you want to make sure that they're actually installed correctly and that they're operating correctly. So if you only test from one window, that window that your frame is in or that your fan is in, you're not going to know about it. So it's easy to move from one window to another. So, good question.
The other nice part about having it in the window is when you're doing your in-progress blow-a-door testing on the structure before any of the drywall goes up, trying to find all those extra leaks. It's a construction site. People are walking in and out, and the luxury of having it in a window as opposed to a door is great because the fan runs automatically. It'll ramp up and ramp down, and you can almost hear when somebody opens the door. But then you just put a note on the door. It says close it right behind it, and then you don't have to take the fan out consistently. I worked on one project where we were actually using only the main entranceway to blow a door test, and having to set it up and break it down, set it up and break it down became tiresome. So now having access to the window frame fan, it makes just perfect sense for me.
Right, and this is a picture that I took at the training center in the Bronx, right? So I mean, you have it set up here at the training center to do that, correct?
Yes, we demonstrate it, and even especially in training, even contractors, it's real easy to set up, throw it in the window, and leave it run, and use the actual blow a door as a tool, along with some of the air current testers or smoke sticks, or ways to actually find the leaks. And using the blow-a door to actually locate the actual individual leak in a passive house is key. You don't want to just mask up and cover over the seals. You want to get exactly to the problem. And the method that we use is to pressurize the building, use that smoke stick to point you right to the exact location of the hole, uncover where the issue is, and seal it properly.
Cool. Yeah, and got another interesting question here. Very good question from Miss Clark. She said, "Why would a window frame have different corners than a door frame?" It doesn't. I'm sorry that I made it sound like that. No, this is the same frame construction as your blower door frame. There's only two differences. One is that it's smaller, and two, it only has one crossbar. With a full-size blower door frame, you're going to have two crossbars. So thank you very much. That's a very, very good question.
I think the point you were referring to is that the corners have been updated for the frame itself. The older corners were a mitered corner of the gaskets of the older frames, and now the newer frames have a continuous gasket all the way around, so you do get a tighter seal.
Right, and that's with that's with the Retrotech frames. I don't do. Is that the same? Is it the same case with the Energy Conservatory frames? I'm not sure.
I'm not sure currently.
Okay. So yeah, and then question here. This might be a better question for you, Kevin. But question was, would you ever recommend using the HRV penetrations for an ear tightness test? Have you ever done that? Would you ever recommend that, Kevin?
Uh, it's not a bad idea. You could use that hole because it's sometimes the size of the duct is the same as the actual small fan there is. But getting that duct sealed and properly sealed over is one of those holes. So you should, whenever you're doing your masking of your ERV in progress, you want to check that seal as well. So I wouldn't use it for my final test, but my in progress test, I'd be happy to use any actual opening in the building that could be tightly sealed. So commonly what we'll do is they may leave a window out, not fully seal it in, and that's the one window that we put the blower door frame in, and that's the one where we're constantly testing from. So if you wanted to take that same strategy of not connecting that one ERV duct and using that as your main port of testing, I would have no problem with that. I think that's a great innovation and idea.
Awesome. So I guess what it comes down to here is that with 340 duct tester plus the DM32 equals success. So this is what success looks like. All right. Sometimes I have to laugh at some of these some of the really cool slides that Joe's made for me. So, big thing about the DM32. So this is something that you're not going to find in any other gauge, the DM2, the DG700, or any gauges before that. And that's the fact that you can actually get the ACH results directly from the gauge. So as you can see here, all you have to do is this is what the gauge looks like. Here we have channel A and channel B. So no matter what it says on channel B, which is my results, I just tap it with my finger. Now once I tap it with my finger, it's going to ask me, I'll go to another screen, and it'll ask me what I want to test at. So then I want to make sure by the same, sorry, I'm going to back up for a second. So here I chose ACH of 50. Next thing you want to do is choose what kind of fan you're using and what kind of ring it has. Same sort of idea. All you have to do is touch the picture of, you don't even have to know the name of the ring, the name of the piece of equipment that you're using. You just basically touch the icon. It'll give you a list of different fans and different flow plugs or flow ranges, and then you touch it, and it's going to take you where you want to be, so you can start actually testing. So, but you want to make sure that you have the volume of the house. So this is sort of the caveat here, is that in order for you to get ACH at 50, you need to know the volume of the house. So you're going to need to calculate that volume of the house, go into the settings, and then actually input that volume into your gauge. But in the meantime, when you're done with your test, you're going to be able to get your ACH at 50. Oh, looks like, and it says I have been updated that you can actually do that with the DM2 as well. So and then here's another question that I get. I can always tell that. So thank you, but again, Miss Clark. So she says that she can actually show ACH at 50 on her DM2 after she types in the volume as well. So that's awesome. I stand corrected. I didn't want to sound too biased. But it looks like Mr. Sims says that, or asks, will a DM32 run an Infotech fan? I don't think so. And Mr. Sims, I'm guessing you're probably from Europe. It seems like the only time I ever get questions about Infotech fans are people from Europe. Yep, UK. Great. Well, yeah, I don't think so. The only thing I could say is you'd have to find out how close the Infotech fan is to the energy conservatory fan. If they're the exact same, if they run on the exact same flow curves, then you could just input it into the DM32 and tell the DM32 that you're running an energy conservatory fan. But I don't. But all I can tell you for sure um, is that if unless they're exactly the same as the energy conservatory fans, you cannot. I apologize for that. A little bit more
Yeah,
about.
just
Yeah, go ahead. Sorry.
jump in, and I think you're getting to it. Is it's really, really important to make sure that your volume is calculated accurately. Work with your passive house consultant and your certifier to make sure that we're all comparing the same numbers. I can give an example of on one project where I personally didn't measure the volume, worked with the certifier, and then realized that we weren't quite at the right volume. So if you change the 33,000 number there, it significantly changes what your ACH at 50 number is. So know that up front, and then also check and confirm before it's a final test for certification. And that knowing what that ACH number is in the gauge, because it's racked into our brains from working within Passive House. Are we going to hit our blower door number, or are we not? How far are we away? And it really does help a lot.
Yeah. Thank you. Perfect for over that. So, to the point that Ms. Clark made earlier about the actual frame, or why would the window frame be different? It's not. This is the same. These are the corners that are going to be ubiquitous for all of our frames. It has larger soft knobs, custom molded handles, and the parts are actually numbered so that it's really easy for you to figure out how to set up. But this is it. So it slides very easily. As you said, Kevin, it's got a continuous gasket so that you can be sure that you're getting a very, very tight seal. It moves very easily. It fits very tightly, and it's easy to take apart. In fact, we don't show it in this video, but actually to take it apart, you just push it. You just squeeze it. So we talked a little bit about why you test at a window, why that's important. Again, I recommend that you test at multiple locations, try different windows. Yeah, the gaskets are much improved. In fact, I think someone mentioned earlier that the new Retrotech frames, Mr. Dunside says that the new Retrotech frames have the quick release and the tech still has the original type. So very different types of corners, connectors, and the frame actually is one of those things that if you're not doing a whole lot of testing, you don't realize how nice those gaskets are and how nice those calipers are. So thank you for mentioning that. This has become this topic right here has become a sort of a pet topic of mine, something that I put together, an idea that I had and that a friend of mine, Pete, improved upon, and that's this reference hose. So for those of you who test regularly out there, I'm sure that you'll understand this. This is something that you already know, but this is a topic that I constantly hammer into the minds of designers, of passive house consultants and architects, everybody, because even though we talked quite a bit about these different sort of standards and the ISO standards and the EN standards and the ASTM standards, it's those are all made to be sort of general to any house. But what I would say is if you're specifically working on a project, a specific house, a specific location, I would want to specify. I would want to standardize where some things. And first thing I would be is where that reference hose goes. So the question to everyone here is, this reference hose, is that okay? Where that is? Let me know. And this question is, please let me know if, yeah, exactly. Mr. Den Hartog, that is very funny. Right. So let me speak to excellent, very Very, very good. Yeah, correct. That is not. So I've got some people in here that are saying that they put it along the foundation. Some people put it in the grass. I have spoken to people who know more about blower doors than most anybody in the world, who say they've put their reference hoses out for days, and they've run these data loggers, and they put it in, or they put it in a bottle, as you say, or as they put it along the foundation. But what I found is many things. Is that I actually like to do this. And this is a very, very simple thing. I'm going to go through this really fast because we don't have too much time. But if you want more information about this, you can either contact me, or I'll put you in contact with a friend of mine in the Netherlands, Ken Hoek. We've been working on this little homemade thing. And basically what this is just a regular container. It's just a container. It used to be, I think, dishwashing detergent. So what I've done here is I've cut a hole in the top here. I've put a tube in there. That tube goes into a tennis ball that I perforated, and my reference hose goes down into it. I've buried that tennis ball under a bunch of big rocks, so it's very heavy. It sits very nicely. It doesn't blow over. It is not an airtight container, so it is open to the pressure, to outside pressures. However, I don't overly perforate it so that we don't get any kind of wind effect on it. So I tried the bottle thing, and I know some really, really smart people who say they just put it in a bottle. But to me, it didn't make any sense, because the way that our flow pickups work in the fan is the Venturi effect. So air moving across the orifice of that bottle is going to cause some kind of suction or some kind of turbulence, right? And then I've heard other people that say, well, stick it into your manometer bag. Well, I've done many combustion zone tests on basements of brick buildings here in Chicago, and seen the windward side of the house be negative, and the windward side of the house be positive, and the leeward side be negative. So the idea that a fabric bag can actually is more wind resistant than a brick house, to me, is ridiculous. So we made this thing. If you want to know more information about it, I'd love to share it with you. It's not a RetroTech product. It's not endorsed by RetroTech. This is simply my opinion. But the idea is basically that you want to make sure that the references are standardized, so that when you're getting your house, this project that you've put your heart and soul and lots of money into, that when it's actually being tested for certification, that it is a fair test. And that's me. So when you have problems, we've got a couple of minutes here. I want to go through these slides but in fact, actually, you know what, Kevin, do you want to spend a couple minutes kind of talking about why there's been such an increase in passive house and what's going on with the business of passive house in North America? Maybe.
Sure. Do you want me to show a few of the slides that maybe I've put together?
Yep, and I'm passing it over to you. So let me talk. I'll talk a little bit while you're getting set up. You're ready to go.
So innovations that have happened in the world of passive house over the past few years. In New York City, where I'm located, the mayor has called on. I wrote a proposal called the One City Built to Last. It's a roadmap for New York City buildings to committing to a 35% energy reductions in emissions by the next 10 years. They specifically say in that document that they're looking at passive house to get them to net zero energy. So our passion here in New York City and involved in New York Passive House is the easiest way to get to net zero is to have the most efficient envelope, enclosure, air tightness, and then put a little bit of renewables on the roof and utilize it in other areas. The other innovations that have happened, this targets the last mayor's goal of 80 by 50 with an 80% reduction, and the way the roadmap they want to get there is passive house. So within the city itself, we've seen the Department of Design Construction recommending passive house in their RFPs for city-owned buildings. We have a Cornell project that's a 26-story dormitory that's going up on Roosevelt Island that's going to be certified to the Passive House International Standard. That's very exciting, seeing that Cornell and their City Tech project is investing in Passive House and the other real estate developers involved in that. We also have Sorry, let me go back here. We also have some other innovations that are coming out of other parts of the country. A good friend, Tim McDonald, who built this Belfields project and Onion Flats, he has worked with the Pennsylvania Housing Finance Authority to put Passive House into the affordable housing language. By doing so, he has spurred a market of Passive House within all of the affordable developers within the Pennsylvania area. So just to give an example of the potential, they got an extra 5 points on their application for having recommended Passive House levels of being pre-certified, engaging with a certifier, and actually shooting for certification. They had 85 proposals put in. 35 of those proposals were 8 of those projects are now Passive House projects. 35 of those projects proposed Passive House, and they were selected. So they're able to achieve Passive House in the affordable market and relatively limiting cost implications. So that's the latest and greatest here on the East Coast that I'm very familiar with. I'm heading out to Vancouver to the North American Passive House Network Conference, and it is my understanding that the City of Vancouver is also looking at Passive House as an equal way for their sustainability initiatives, and it's a really proactive state. So that's the current state of Passive House. I'll turn it back over to you, Jay.
Thank you, sir. So we have a few questions here. Looks like Eric Bjornson will see you there, Kevin. So be on your best behavior. Um, Someone said, I've heard using a fish tank aerating stone. Yeah, that's what I like to use. Jay Edmonds says hi. Jay, come on now. But so right now, we have basically, I think we've come to the conclusion of all of our, or sort of met all of our all of our learning objectives here. Um, so it is. I want to leave it up to everybody out there if they want to stay on. It's 2 o'clock, so you can sign off and still get your CEUs. For those of you, especially want to thank those of you who signed in from Europe or other time zones where it's very late. Hopefully you enjoyed it and you found this useful. For those of you who want to stick around, we can do about 15 more minutes of question and answer if you like. And as I wait for those questions, I'll kind of go through some other slides that I put together. So I want to ask you a question out there in the world. Kevin, can you stick around for 15 more minutes?
Of course.
Okay, so what would you rather talk about? I've got two other subjects that I want. Thank you, Nate Price. I've got two other subjects that I'd like to cover, or that I can cover if you want. One is how do you find those holes? So assuming that you did your test, but your test did not pass, you did not reach certification, then how do you fix that? My other question, or my other subject that you might be interested in, is using equipment to test HRVs or ERVs, which is not a air tightness test, but it is another certification test that is that you're going to want to do to make sure that your equipment is installed correctly. So fixing air leakage problems or ERV, HRV. Finding leaks. All right, the ladies first. Okay, so let's talk about finding leaks. So the main thing in your design, or in that proper design, is you want to have a continuity of air air barrier. So here we have a discontinuity. That's for you non-English primary English speakers. That's just the opposite of continuity. The point being that if your design or if your installation does not have an air barrier that is continuous, that is in constant contact, that's a problem. And so where do these problems most commonly found? Most commonly found at the connections. So the connections of different parts of the house, the roof to the wall to the other wall, or the wall to the floor. Even on some of these seam connections, or where the parapet overlooks or meets meets the roof. So these are the first places that you want to look. Kevin, I know that you've done plenty of this. What is this pretty much a? Do you think this is an exhaustive list of the places that you would look first, or where else would you look?
No, so it's a system. It's a perfect way to look. It's about air barrier systems coming together with possible vapor barrier systems or roofing systems. So in the picture to the left, that is the Proclima product being put on the exterior wall, and it's continuing straight up to the roof. The only area that you would really have to worry about continuity or finding other leaks is where it's connecting down to the foundation. So what is that system? How is it made? What's the connection detail? And was it sequenced properly? That's really where the passive house tradespersons are earning their stripes out in the field. And the systems that are in place that are shown in commonly worked within the passive house world are using tapes and membranes for their flexibility, that they're able to make those connections, that they're durable under many different stresses, and that they're going to last a long time.
Right.
So those are great options.
So I was at Raider Fest about a week ago, and I had a chance to listen to Justin Wilson from Construction Instruction, and this guy is fantastic. And he actually showed some pictures of some fluid applied products that have a limitation of heat. So they were some fluid applied products that were applied to walls to make air barriers, or and they melted. So that's another thing I think is another reason why I really like these, these sheets or rolled on or pieces or membranes, is that you don't have to worry about some of those idiosyncrasies.
Yeah,
And
it's there's plenty of opportunities for things to possibly go wrong. Work with your design team, your certifier, to make sure all the systems are complete and connected. One of the things we talk about in a lot of the trainings is doing that red dot or that red pen test. Make sure that throughout your construction details you can label what those connections are, how are they going to be made, what materials you're going to use. If you're putting on any concrete or plywood, make sure you're using primer based on that system. But the penetrations that you're showing here, from windows to pipes to continuous air seal around all of those openings, the pipes using the grommets and the gaskets, give those to the guys working in the trades, the plumbers, the electricians. Let them put the grommets on, and then you do the air sealing. The wires, make sure there's a penetration plan, that all the penetrations are made with airtight materials and that they can be sealed, and hopefully you can keep them inside the enclosure. And then the beams. So if you are incorporating any wood beams or any kind of structural beams into your airtight layer, it's always a difficult task to seal up a joist for 40 feet that's penetrated on both sides, 16 on center. And if they're 2x10s, by 2x10 inch, you can have up to 26 linear inches of tape to make sure all those penetrations are sealed, and that could work out to a lot of labor. So if you can avoid that by sequencing in some material, it always does help.
what does sequencing mean?
So for example, those rafters there, before those rafters were going to be placed in, you would just sequence a piece of that membrane flexible material over the top side of where it sits, back up again and over. So it's what we know in the world of passive house is a floppy bit. So rather than using a lot of tape and a lot of prep time, you use the actual flexible nature of the material to sequence in that achieves the air tightness layer. So you're avoiding lots of labor and lots of prep work and lots of material by thinking smart, and it's just planning up front for your air tightness.
Cool, thank you. So and I think the next question is, so we kind of talked about designing it, or places to look, where weak spots where to look, but if you're still not meeting those, there's a number of different sort of diagnostic accessories or airflow testers that you've discussed, Kevin. But basically what I would say is there's generally, to my mind, three general sorts. There's these sort of lighter than air, these sort of powdery based ones that are very light. These are usually very innocuous, not they don't cause, they're not noxious, they're not poisonous, they're not problematic extensive or to a high degree, but they're not lighter than air. They run out fairly quickly, and they can cause some dustiness. Here you're going to see the what's the chemical based, the Retrotech flow or airflow finder that we sell. I will tell you this, that these are my absolute favorite personally before I even came to Retrotech, because they react very quickly. They make a good smoke. They are very dangerous for your pieces of your equipment. It can cause big problems in an equipment box, so you need to make sure that they're kept in the container. And at this point, in North America, these are considered hazardous materials, so shipping them is incredibly expensive. And if you try and fly with these, I bid you good luck, because if you get caught with this, they will take it away. So these are very difficult to find. So this is an older kind of dragon stick. This is sort of works on the same way that the smoke that you'll see at a nightclub, or wherever you're wherever you hang out. It's a sort of a small theatrical smoke machine. They have some improvements on this, but basically it heats up oil and it makes a little bit of smoke. There are some new improvements, and you can actually find the newer and improved ones, and they sell online at retrotech.com. And then, of course, you can use, massive amounts of theatrical smoke. You can actually pump the house full of it, pressurize it, and look for smoke coming out.
Just be
Sorry, go ahead,
sure to
John.
let your local just be sure to let your local fire company know that you are doing such a test. You don't want the guys responding to what they think is an emergency when it's just an actual simulated test.
Good point. Has that happened to you before?
It hasn't happened to me, but I have had a few people come up to me and tell me stories about how they had their local fire department respond to an emergency that wasn't quite an emergency. So just be careful. Your neighbors are always watching and looking and trying to keep their neighborhood safe. So just be sure to let everyone know and let those municipalities know.
Right. Good point. And of course, there is everybody's favorite, the IR camera, the infrared, the thermographic camera. So these are still, obviously the cousin to the blower door. You can see plenty of things with an IR camera, but when you pressurize or depressurize a house, you can actually get very nice, really, really good imagery at a temperature difference between the inside and the outside of as low as 8 degrees. So that's really, really important. I will say this as we close out on this particular subject: there are products on the out in retail off the shelf now. I don't know how easy they are to get, in the UK, but you're right. There's a floor for the iPhone that connect to your iPhone. I think that's about 600, $700. There's actually a freestanding one that I like a lot. $600, $700. When you're looking for air leakage, it is absolutely perfect. I think it's fantastic. It's very light. It's very tiny, and it's a tenth of the cost. So that's the extra bonus 15 minutes for all of you that stuck it out. For all of you who I think Hans said are passionate and willing to sacrifice a little bit more time. Scott Mills says it's $250. Wow, the one for the iPhone, awesome. So the iPhone edition is only $250. And then the freestanding one I think is about $600. So it's well within I think your price range now. In fact, with the way that the amount of money that it actually costs to ship the older smoke sticks, as we call them, or the flow finder, or not the flow finders, I'm sorry, but it's close to that cost. So any other questions while I wait for your questions to come in? Do I recommend the iPhone version for the IR? I don't make any recommendations. Um, I've never used it. So there's a person on the call, Scott, Mr. Mills. Do you recommend it? So yeah, Jay from Retrotech says shipping of the air current tester is about $280. That's for one air current tester or 200. So the point is that if you're just going to order one air current tester, you might as well just buy an iPhone thermal imaging. But Mr. Mills, do you recommend it? Have you used it?
Yeah, just to touch on a point,
Yep.
that the in order to actually get a good thermal image of air leaks, there has to be some thermal mass. So the air leak needs to run over a surface. So it has to be drywall or gypsum or something. So when we were going on a few of our projects looking for leaks and using the thermal imaging camera and it's going over those very thin membranes, we weren't seeing the leaks that we were hoping to see. So the visual image for trying to get through the thin membranes, it doesn't really work all that well. It has to be either really, really cold on the outside or you have to see that. But normally what you're seeing is the cooling effect of the air running across the surface and then chilling that thermal mass of that drywall. So the magic bullet of IR within Passive House, it will help you find leakage without a doubt under the finish conditions. But when most times we're doing that in-progress air leakage test, when we're running, say, over across the surface of a membrane, just be aware that you may not be able to use the IR camera.
Yeah, good point. And so, thank you, Mr. Mills, for your input about the iPhone edition. So, Ms. Clark, Mr. Mills says that he has one. It works for testing. He says, but you do need about a 20-degree, and I assume that's Fahrenheit, 20-degree temperature difference. I'm really trying not to say delta T to actually get good photos. Um, And at what stage would you carry out the in-progress test, Kevin?
So you would need to have almost the entire enclosure complete, meaning that the windows are in, hopefully most of the doors are in, the skylights, if there are any, and the air barrier is intact and complete. So that's a perfect world. There are some cases on many of the products that we work on that the skylight is 6 weeks out, but we need to start putting drywall up. So we feel comfortable that we can mask up one or two openings and commission that air barrier system and get some good readings on those areas. So we're doing really a visual confirmation of all the joints and intersections and the tapes that we can see, smoke checking them, and knowing that our number is pretty close to what our goal is, and then we can successfully say, hey, we're going to put up some drywall. So very similar.
All right. Thanks, Kevin. So thanks
Thank you.
everybody for sticking around. We really appreciate it. Thanks again, Kevin, for all your help, especially for making sure that we could actually start on time. Thank you all for coming. I hope that you found this useful.